In this video, we'll be talking about symmetry of the graph, okay? Sometimes the graph is symmetric about y-axis, sometimes the graph is symmetric about x-axis. So what does that mean? So this graph, you can see that if you cut the graph in the middle, meaning that about y-axis, and then if you fold it, then these two pieces completely or perfectly overlap to each other. They coincide to each other, right? So that's why this is the mirror line like that. And you can see that the image is exactly same as the original shape. Okay, so in this case we call that this graph is symmetric about this vertical axis, that is the y-axis. Okay, so this graph is symmetric about y-axis because if you cut it through y-axis and then fold it, then these two pieces perfectly coincide to each other. Okay, but this graph, you can see that if you cut it about y-axis, then you don't get anything there. But if you cut it through x-axis though, and then fold it, these two pieces, they perfectly coincide to each other. So this is symmetric about x-axis. Okay, so if the graph is given, then you will know, you can see that whether it is symmetric about x-axis or y-axis. But sometimes equation will be given to you. How do we determine from a given equation whether the graph of that equation is symmetric about x-axis or y-axis? You can see here that this graph is symmetric about y-axis, right? When the graph is symmetric about y-axis, you can see that 2, 4, or you can say xy and then negative xy belong to the same graph, right? You can say 2, 4, this point is 2, 4, and the other point is the image. You can see that it's like a mirror, you can think, and negative 2, 4 both belong to the same graph. In other words, if a graph is symmetric about y-axis, then x comma y and negative x comma y, both x and negative x comma y will be in that graph. But in this case, you see that this is x, y, this is also x, y, x and negative y, right? If the graph is symmetric about x-axis, you can see that the x is same but y changed by negative y. So both of these points fall in that graph. There is another even easier way to do that. So if replacing x by negative x, see, x and negative x gives the same equation, then the graph is symmetric about y-axis. What does that mean? If you replace x by all the x by negative x into that equation, and if you get the same equation, if there is no change in the equation, then it is symmetric about y-axis. Remember, for y-axis, replace x by negative x. For x-axis though, we'll replace y by negative y because see, y and negative y both belong to that graph. That's the reason. Okay, so let's take in this example, if you replace x by negative x, what do you get? Y equals to negative x squared and then minus 1. If you simplify this, you will get y equals to x squared minus 1. So this is same as the original equation. Did you see that? So when you replace x by negative x, you get exactly the same equation as given. Okay, so this equation is symmetric about y-axis. But here, for the x-axis though, if you replace y by negative y and get the same equation, then this equation, the graph of this equation is symmetric about x-axis. Let's check for this one. Okay, so we replace y by negative y for this. So in this equation, just keep x as it is, just change y, just replace y by negative y. Negative y squared equals to 0. Okay, so it is x minus negative y squared will be just y squared equals to 0. So you got this equation exactly same as the given equation. Okay, so when y is replaced by negative y, and if you get exactly the same equation, so this graph, the graph of this equation is symmetric about x-axis. Okay, so this is basically symmetric about x-axis. This was symmetric about y-axis. Okay, let me ask you this. So what do you think? We don't know the graph here. If the graph is given like this, then you can see the graph and then tell me whether it is symmetric about x-axis or y-axis, right? But if the graph is not given, if the equation is given, how do we check that? What we do, we first check if it is symmetric about x-axis or not. So how do we check that? So we replace y by negative y. If you see this example, if you change y to negative y, and then if you still get the same equation, no change in the equation, then that graph is symmetric about x-axis. But if you change x by negative x to negative x and then get the same equation, that will be about y-axis. Let's do that. So let's change x by negative x for y-axis. X by negative x. What do you get? Negative x to the cubed plus y squared. You don't do anything with y though. When you do this, when you replace y by x by negative x, equals to negative x. What do you get? What is negative x to the cube? Negative x times negative x will be positive, double negative, will be positive x squared, and then times negative x will be negative x cubed plus y squared equals to negative x. Is this same as that one? Let's see. X cubed and x cubed, they have different sign, and y squared have the same sign. So these two equations are not same. So it is not symmetric about y-axis. Okay, next thing, let's do the next. So how about replacing y, changing y to negative y by negative y? What happens? Let me keep x same and then replace y by negative y, so you will get y squared equals to x. So what do you get? You get x cubed plus y squared equals to x. You got exactly the same equation with the given equation, right? So this is symmetric about x-axis. So symmetric about x-axis. So this is how we check whether the graph of a function is symmetric about x-axis or y-axis or not. Sometimes a graph can be symmetric about both x-axis and y-axis. Can you think of that type of example? Let me give you this example. How about x squared plus y squared equals to 9? So is this symmetric about x-axis? You replace y by negative y. It will be x squared plus negative y squared is basically plus y squared equals to 9. Yes, it is symmetric about x-axis. How about replacing x by negative x? You get exactly the same equation. So this is both symmetric about x-axis and y-axis. How does the graph of this look like? Have you imagined that? The graph is like this. This is a circle with center at origin. So it is, if you cut it through y-axis and then overlap it, just fold it, you will get exactly the overlapping shape, right? Similarly, if you cut it horizontally, you will get the same thing. That's why this equation is symmetric about x-axis and y-axis. There is one more type of symmetry that is called symmetry about origin. Okay, so for the symmetric about origin, as you remember that for the symmetric about x-axis, you replace y by negative y and get the same equation. If you get the same equation, that is symmetric about x-axis. Similarly, for symmetric about y-axis, you replace x by negative x. If you get the same equation without replacing x by negative x, then you will say that the graph of that function or the graph of the equation is symmetric about y-axis. Okay, but the thing is, if you replace x by negative x and y by negative y at the same time, and if you still get the same equation before replacing and after replacing, then the graph is called symmetric about origin. Let me give you one example here. So here the equation is x squared plus y squared equals to xy. So what we are going to do here is replace x by negative x and y by negative y at the same time. If you want to see the symmetric about x-axis only, you replace y by negative y and then see if you get the same equation or not. For x-axis only, replace y by negative y. For y-axis only, you replace x by negative x, and then say. But for the origin, you do both at the same time. So you replace x by negative x, and then y by negative y. So what do you get? So you will get negative x squared plus negative y squared equals to negative x, negative y. Do you get the same equation as this or not? Let's see. Negative x squared is negative x times negative x, right? So that is negative times negative. Double negative squared is x squared plus negative y squared is again y squared equals to negative negative double negative xy. So that is xy. So you got exactly the same equation with this one, right? So this is symmetric about origin. Symmetric about origin. Do you think that this equation is symmetric about x-axis? So for x-axis, what do? You interchange or you replace x by negative x and then y by for x-axis you replace y by negative y. Let's check that. Is it symmetric about x-axis or not? For x-axis, what do? Interchange y by negative y and then see. Okay, let's do that. So keep x squared as it is plus y by negative y equals to x and then y by negative y. So what do you get? Negative. So it will be negative y, right? What do you get? X squared. This is plus y squared equals to negative xy. So is this same as that one? No. So this is not symmetric about x-axis. So similarly, if you check for y-axis, you will get the same thing. It is not symmetric about x-axis, not symmetric about y-axis, but this is symmetric about origin. All right. So let me take one more example. That is the final example. Test for symmetry of this. So what we do, we check for x-axis. First, let's check for x-axis. For x-axis, you replace y by negative y. So negative y equals to x squared plus 1 over x squared minus 1. Is this same as that? No, because everything on the right hand side is good, but the left hand side you got the different sign. So this is not. So not symmetric about x-axis. Let's do for y-axis. For y-axis, you replace y by x by negative x. Keep y same and x by negative x squared plus 1 over negative x squared plus 1. What do you get? Y equals to x squared plus 1 over x squared plus 1. X squared minus 1, right? Minus 1. Oh yes, this is same as the original equation. So the answer is yes. It is symmetric about y-axis. How about the origin? How about the origin? Let's do that. For origin, you replace x by negative x, y by negative y. So what do you get? Negative y equals to negative x squared plus 1 over negative x squared minus 1. Do you get the same equation or not? Let's do that. Minus y, negative y equals to x squared, because negative x squared is x squared plus 1 over x squared minus 1. Is this same as the given equation? No, because the left hand side is different, right? So the answer is no. It is not symmetric about origin. Okay, so this is how we find, we check or we test whether a given equation is symmetric about x-axis or y-axis or sometimes both or origin. All right, thank you.